name's Ken Kylanen. I'm with the Oil Filtration Systems in Boerne, Texas, just outside of San Antonio. We're coming to you this morning from our offices here in Boerne. And today I'd like to show you guys how to use our portable fluid analysis kit to analyze and evaluate oil samples for particulate contamination and water contamination. The patch kit, so it's called, enables you to assign 3-digit ISO cleanliness code to an oil sample in about 5 minutes. And also it enables you to assign a water content in ppm in about 5 minutes. So I'd like to show you guys how to use this properly. It's very simple, very valuable tool for use in the field when you don't have necessarily time to wait for a 2 to 3 days for a lab result to come back. And we use this kit quite a bit in the field to get instant results, so you can get a good feel right away for the cleanliness of your oil. So today I'm gonna run a patch on a sample of ISO 32 turbine oil. First thing you do is you set up the vacuum pump like so. Stands up on its own. You've got a funnel that fits in here with an O-ring seal, and then you tighten this down so it forms a good seal. This part of the funnel is removable, and you put the patch on top of this. So the first thing you do is you want to clean the funnel. So you wash down any particulate contamination that is on the funnel. And the way you do this, the reagent here is nothing more than odorless mineral spirits, very common. You can get it at a hardware store, Home Depot, any paint supply store has odorless mineral spirits. So we got a squirt bottle. Now this is not necessarily clean, coming straight out of the can from Home Depot. So part of the kit is a small filter that you put on the end of the squirt bottle. And if I were to squeeze this now, this filter would blow off. So while I'm doing it, I hold this filter in place. And all I'm doing is washing down the walls of the funnel with filtered odorless mineral spirits. And you pull that through. Just by engaging this, it sucks any fluid through the funnel. So then we have our patch membrane. This is a 0.8 micron patch. The kit comes with 2 micron sizes. It comes with both 5 micron and 0.8 micron. I'm using the 0.8 on turbine oil. The hardest part of this whole thing is getting the patch with your forceps, because each patch is separated by a little blue piece of paper. And so you gotta, okay, there's the patch. You don't wanna get the blue paper because it's not permeable. Nothing will flow through it. I just dropped the patch. Let me grab another one. Like I said, this can be the The hardest part of the whole process is grabbing this patch membrane. Okay. The patch is on the funnel. What you do is you measure out 25 milliliters of oil into the funnel, and there's a marker there. You always want to shake up your oil sample, make sure that any contaminant has not settled to the bottom. And then you pour in up to the 25 milliliter sample point. Now, by actuating the vacuum pump, this will pull all of the oil through the patch into this bottom sector. And any particulate contamination at all that's in the oil is going to get trapped on that patch. So this typically takes a minute or so for the whole oil sample to pass through the patch. In the meantime, we can get the index card ready. This is just a pre-printed index card that we're going to put the patch on once it's ready. And then we have a laminate sheet which seals the patch sample onto the index card. So you want to do this typically inside of an enclosed area, out of the wind, outside of the elements. You don't want any contamination getting into the funnel, which would then taint your patch test. So we usually do this inside of an office, inside a doghouse when you're out on job site, any indoor space where the wind's not blowing and it's not dusty. Sometimes when this is high viscosity oil, this process can take quite a bit of time, a couple minutes. One trick that you can do with higher viscosity oils is to heat the oil sample, and putting the bottle in front of a heater on even inside your truck on a cold day can effectively heat up the oil sample and make it flow quite a bit easier through the patch. So this sample is almost all the way through. There it is. Now, before just pulling the patch off and setting it on the index card, we wash down the walls again just to get any residual oil that's on the walls of the funnel. And this just ensures that you're getting every bit of the particulate contamination that might be in the oil through the patch. So once that's done, you get your laminate sheet ready. Pull the patch membrane off of the device. There's a little notch there that facilitates it. Put it on your index card, and then you seal it with the laminate. So now you have your patch on your index card. It's sealed with the laminate sheet, and you can now look at it through a 100x microscope, which is part of the kit. This one is a mechanical microscope. A version of the kit also includes a digital microscope where you can hook it up with a USB port to your computer, look at the patch on your screen, and actually download data so you can create reports and things like that with a digital microscope. This one, however, is not digital. So what you do is you focus it in on the particles. And then once you've got it focused, you move the entire microscope around on the screen or on the patch so you can get a representative view of the particle count distribution on the patch. And it's usually very uniform. You're not going to have parts of the patch with a whole bunch of particles and another part with nothing on it. It's usually a pretty consistent distribution of particles across the patch. So what you do then is, using the comparator booklet, there are views of known ISO cleanliness code numbers in the comparator booklet. For instance, this one here says ISO 161512, and this view is what ISO 161512 looks like through a 100x microscope. Similarly, 151411, 181613, and there's just a range of different particle ISO cleanliness codes all the way up to 232219. So the way you do this is you look through the screen, moving the viewpoint around so you see the most representative distribution of particles. You compare what you're seeing here with known quantities in the comparator booklet. And by doing that, you can say, okay, this view looks most like ISO 181613. And that's how you assign a 3-digit cleanliness code, ISO cleanliness code, to that oil sample. It's a relative way of doing it based on known values. And we've been doing this, using this kit for about 20 years. If I were to send this sample off to a lab and get a result, what we found is that it's surprisingly accurate how closely you can assign a 3-digit number. Almost always within 1 digit is how accurate we can do this, because the difference between 181613 and 191714 is really quite significant when you're looking at it through a microscope. It's literally twice as many particles. So it's really a quick, easy way to assign that ISO, the 3-digit ISO cleanliness code, and it is really quite accurate as well. All of the instructions, everything I'm talking about and going through here are also included in this comparator booklet, along with an explanation of ISO cleanliness code as it relates to NAS class and different ways of measuring. It explains the ISO cleanliness code. Another benefit of the patch test, other than just giving you a 3-digit ISO cleanliness code, is you can actually see the particles and see what they are. You can't always identify exactly what they are, but fibers are very obvious. Metal fines are shiny. Little bits of aluminum will be very shiny. Sand particles, silica are fairly obvious. So it is quite interesting. Rust particles are going to be reddish. You can actually see the particles, and it sometimes helps determine what your contamination is. So the other part of the kit then is a moisture water analysis tester. And the way this device works is with a powder reagent and the same exact liquid reagent as the particle kit. So the way you do this to make it easy for the proper amounts, because you have to mix a certain amount of reagents with the oil inside of this vessel. So I'm going to pour some of this in here to make it easier to pull out with a syringe. The kit comes with 2 syringes, a 30 milliliter and a 10 milliliter. So to do this, you take 30 milliliters of oil. You make sure we've got instructions. You take a 30 milliliter sample of oil. Got to be careful not to spill. Okay. 30 milliliters of oil goes in a certain, there's 2 sections of this container. There's the main body of it, and then there's a shelf that has a separate container. So you put 30 milliliters of oil in there. Then you take 10 milliliters of your liquid reagent. So 30 and 10. And you mix this with the oil. Then you have your powder reagent. And what this is calcium hydride. It reacts with water. So this is a hazardous substance. It's not super hazardous, but you do want to be careful. You don't want to get it in your eyes. So you just handle it carefully. Comes with a small spoon. And in this separate section of this vessel, separate from the oil and reagent mixture, you put 3 spoonfuls of this powder reagent. It says heaping spoonfuls, so I'm not really tapping them off or anything, and I just put that in. So nothing has really mixed together yet, other than the oil and the odorless mineral spirits. So once you've done that, you close the lid. On top is a pressure gauge. It's 0 to 15 PSI. This is a vent port. So you vent it. And now you want to mix this up. So you're going to shake. And what it prescribes is you shake for 20 seconds to begin with. And if there's a whole lot of water, you're going to get pressure right away. And so you don't want to shake for more than about 20 seconds. And then you double check your gauge reading and make sure that it hasn't already pegged. This is quite dry oil, so I don't expect there to be very much water in it at all. It hasn't read any PSI just yet. So it prescribes to shake for a full minute. Then on this PSI gauge, 1 PSI equals 100 ppm. So without any reaction here, this does not register any water content. So this is extremely dry oil. If it were wet, again, if it went up to 3 PSI, that would mean you have 300 ppm of water in the oil. And so it goes all the way up to 15 PSI. So it'll measure up to 1500 ppm, which typically pretty good indication of your water. It's accurate to say the nearest 100 ppm, generally speaking. So it's not nearly as accurate as say a Carl Fisher titrator, but that is a laboratory piece of equipment, cost about $6,000. This is a good field kit and a good way to quickly and a fairly inexpensive way to analyze an oil sample and tell you how much water content is in the oil. So that's basically it from the patch test for particulate to the water test kit for moisture. This is a fairly inexpensive way and definitely a quick and convenient way to test oil samples for both ISO cleanliness code, assigning it a 3-digit ISO cleanliness code, and also assigning it with a ppm water content. The patch test portable fluid analysis kit. You guys, if you have any questions, you can reach us on our website and on my email. It's www.oilfiltrationsystems.com. If you have any questions at all, feel free to email or call. Thank you very much.